All right, guys, let's take a look at constructing and interpreting linear functions. Now, in future slides, we're going to talk a little bit more. We already talked about functions, and functions have one input, one output. Linear is just a fancy way of saying a straight line. So there's a couple formulas on the formula sheet that relate to linear functions. We have the slope-intercept form. That's this y equals mx plus b. You would find that especially for these ones that we have down here, where there's like a definite point where it touches the y-axis. That would be the slope-intercept form. We have the point-slope form, which is when they give you a point that's just somewhere in the quadrants and you know the slope, but you might not know the intercept. That's when you would use point-slope form. And then the standard form is something else you can use. Honestly, I don't really use that so much. I use the other ones the most. All right, let's take a look at comparing and constructing these linear functions. So one of the things that you will need to know how to do is you're going to need to know how to interpret what functions mean. And so, for example, if we take a look here, it says for your birthday you get $100. That $100 is your starting or initial value. Anytime you have a y-intercept, that's where we start. So we're starting at $100. Then, because you love to go to the bookstore, every week you spend $5 on a book. Like, this must be an old example because books are not $5 anymore. But because you do it each week, almost always when you see the word each, it's going to mean multiply. Now, not only are you doing it each week, the other thing that's happening is you're spending money. It's not like each week I give you $5 because you mow my lawn. It's like you're spending money. So because you're spending money, your money is going down. So it's going to have a negative slope. So what we've got here is 100 is my starting value, and then I'm spending each week. So that's how they graphed it. Okay, let's take a look at this next one. This next one, it says you own a bakery that makes muffins. The graph below represents the number or the dozens of muffins that you have, y, as a function as the number of hours worked, x. Write the function for the situation. So here, what we're going to need to do is if we still use the slope-intercept form, which makes sense to use, we have to figure out, okay, well, how much would I have at kind of like 0? And basically, you have to work backwards. So first, here's our graph. Looking at this graph that it gives us, we can see our value is right here at 2.5. Now, it could have been 2.46 or 2.48, so I'll talk about how you could figure out how to do it. But the main thing is knowing how to find slope. And you're going to talk about slope again like around slide 70 when we talk about parallel and perpendicular slopes. But the thing with the slope is use the calculator. See how this formula that they give it to you? Watch what happens when I use the calculator. I'm going to go back up and I'm going to just open it up as the scientific calculator. You could do it on the graphing calculator. It doesn't matter. And here's the trick. Just write the equation. I'm going to put y2 minus y1. Well, actually, first hit the divide symbol. So I'm going to first divide. So the top I have y2 minus y1. And on the bottom I have x2 minus x1. Where did I get that? From the formula sheet. Like, look at the formula sheet. That's it. It gives it to you. So now it's like, well, what's my x and my y? Remember, just like the alphabet, A, B, C, D, E, F, G, x comes before y. For the same thing happens with coordinates. So if I look here, my x's are 3 and 7. So I'm just going to change this to 3 and 7. And I like to go in order. It doesn't matter if you did 7 minus 3 as long as you maintained it. And then the y's go on the top, and that is 4 and 6. So I'm going to put 4 first here, and I'm going to put 6 here. And look what happens. It gives me the slope. Now, in this case, it wants the slope as a decimal, so that's where the 0.5 comes in. Oftentimes, we do use fractions, so anytime you see the fraction button, here's a free tip for later. It's a rational number because rational numbers can be put in as fractions, but we'll talk about that on a different slide. But I see this fraction button, so I can click, and I could also have 1/2 x. And that's pretty much how it works. It's as simple as that. So now we know we have the 1/2 x. We can see the change at 2.5, and everything works. All right, let's move on to this next one. It says write a linear equation that gives this particular rule. Basically, you can type it into the graphing calculator to get your y equals mx plus b, but really you still need to do the slope. So let's just go ahead and do the slope. And remember, the slope is the division symbol, and we want to do the y's minus the x's. So I'm going to do negative 433 minus, I'm sorry, the y's are in the numerator, the x's are in the denominator. And then here I've got 159 minus 107. I would probably just go right to the calculator because I'm used to it, so I know my y's go first. Now look what happens. Make sure that you put in the two negatives because we're subtracting. And what are we subtracting? We're subtracting the negative 277. And then I just do the matching y or x's to go with it in the same order. And there we go. Now let's say you switched it up. Let's say instead you're like, well, Dr. Ihrig, what if I want to do negative 277 minus negative 433? And then if you do that first, then you would just do 107 minus 159, and you get the same answer. It works as long as you keep it. If you go from bottom to top, keep your bottom to top. If you go from top to bottom, then keep your top to bottom. Okay, so we know our slope is negative 3. Now, what we have to do is, this is where you would have to work backwards to get this b value. So we're just going to pick any point. I'll pick this one. And what I'm going to do is I'm going to substitute it in to get my b point. And let's say you're not very good at multiplying. So what? Use the calculator. Negative 3 times 263. That gives me negative 789. So I multiplied first. And then I need to get rid of this negative 789. So the inverse operation would be adding. This cancels. So now I'm just doing negative 745 plus the 789 because I'm doing the inverse operation. And I get positive 44. And then when I substitute it, here we go. That's my correct answer. Now, let's say you want to test your work, because you know how much I'm like, just double check your work, because who knows if you made a mistake. So then all we're going to do is go to the graphing calculator and type in the equation we came up with. I'm going to type in, remember, anytime we want to do substitution, just instead of writing y, just write f of x. Like you should just be writing f of x all the time and not even typing in y. So I've got negative 3x plus 44. And if I really have to zoom to see this. Okay? So now we just test it out. I'm going to type in f of 107, and if I did it right, I should get negative 277, which I did. If I do f of 159, as 159 is my input, my output is negative 433. If I do f of 211 as my input, my output is negative 589. And if I do f of 263 as my input, I get the negative 745. So I just checked my work. So sometimes you might not be able to use the calculator too much to solve the problem, but you can certainly use the calculator to check your work. Let's do a little copy here just to give you a picture, just in case. All right, let's look at this last one real quick. We're basically just interpreting this graph. Okay, so the starting value would be right here. This is my initial value. So it says taxi costs. So my initial cost is, well, this goes up. Notice how there's 2 boxes to get to 4. So that means this is 2, 4, 6, 8, 10. And if I were you, I would just fill in the boxes so you don't get confused. So because this is in between, we know this is 3. They're not going to be mean and make it like $3.02. They're going to keep it simple. So my initial cost is $3 just to get in the taxi. But then I have to figure out, so that's my plus B value. Okay, so that $3 is my plus B. But now I need to figure out the slope. So there's a couple ways you can do it. I'm going to just say, well, if that's 3, this has to be 7. This is 2, so that means this half point is 1. So I'm just going to add these in to make my life easier. So this point, if I use my first point, I have over 0 up 3. But I don't have to do that. I could use this point, which is 2, 7. And I don't have to do that. I could use this point, which is 4, 11. It doesn't matter. But once you have those points, what you're going to do is you're going to use the slope formula that I already showed you. We hit the divide symbol. And my top, remember the formula is y2 minus y1 divided by x2 minus x1. Okay, so all I need to do is type in and substitute my points. I have 7 here for my y. Here's 3. Here I have 2. And here I have 0. And my slope is 2. So I just have 2x plus 3. All right, guys, you got this. See you later.